Alright guys, welcome to this page of the notes. What we're going to do now is take a look at our second option. If I don't have a GCF, how do I factor? Well, option number 2 in our factoring method chart, our table, our list of factoring methods, was a difference of squares. So let's go ahead and take a look at how this difference of squares is going to work. Again, I just want to show you that what's going to happen here in our first example problem is I'm going to start off by looking for a GCF, right? What is the greatest common factor between x squared and a minus 4? And it turns out that there isn't one, right? I don't have an x over here that I could pull out of both, and I don't have a constant other than 1, right? And I certainly could pull the 1 out, but remember, if I pull out a 1, it doesn't actually change these guys at all. I would still have x squared minus 4. So these don't have a GCF, and I'm forced then to go to my second option for factoring, which would be a difference of squares. Now, in order to do the difference of squares, you guys do need to know the formula. You will need to memorize this formula. I will not give it to you on a test or a quiz. So make sure that you just write this down enough times. Again, we will use it enough times that you should be able to remember it. But this is your difference of squares formula, and here's what I'm looking for. If I have some number squared minus another number squared, if that happens, a number squared minus another number squared, it's a difference of squares. And I'll just simply write it as a minus b times the quantity a plus b, right? And all you need to know are what are these numbers. What number is being squared and what number here is being squared. You'll know your a and b, and we'll take a look at how it works in example problems. I promise it'll make perfect sense. Before we do that though, because we're looking for numbers that are being squared, you guys will need to know several of the perfect squares, and here they are. You actually will need to know, you should know more than these, you should, but definitely make sure that you know the first 10 perfect squares. So let's go ahead and list them out right here. 1 times 1 is 1, 2 times 2, 4, 3 times 3, 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. Here's a list of our first 10 perfect squares. Again, you should know this list forward and backward. In fact, you should know this list well enough that if you see one of those numbers, you should immediately recognize it as a perfect square. So here we go. Let's jump right into these. Let's take a look at how they work. All right, I got x squared minus 4, and right away, I recognize 4 as one of my perfect squares. I get 4 by doing 2 squared, and that's how we're going to write it. I have x squared minus 2 squared. That's how I get a 4. Well, now I know my a and my b. So I go ahead and write my factors. It's going to be a, which is x, minus b, which is 2, and a, which is x, plus b, which is 2. Right? So as soon as I recognize this is a difference of squares, I write it as a difference of squares, x squared minus my b squared, my b being a 2. And once I've got this, now I know my a and my b, you just go ahead and write your factors. They are just that simple. Let's go ahead and try a couple more. Here we go. Right away, actually, they need to be equal to 0. So I got a little bit of work to do. I have to subtract that 64 to the other side first. X squared minus 64 is equal to 0. Well, now that I moved the 64 to the other side, I should immediately recognize 64 as one of my perfect squares. I know it's 8 times 8, so I'm going to rewrite this as an x squared minus 8 squared. And now I know my A and my B. X minus 8, X plus 8. Those are my factors. That's what I'm looking for, my answer, my factors. Actually here, let me box my factors in the first one as well. Nope. Right, because I asked you to factor, right? So I've got my factors. Actually, let me go ahead and make this one more real quick note here before we go ahead and move on. Right, these are going to be equal to 0, right? Because my equation is equal to 0. I could ask you to solve these, right? In which case you'd use the zero product property to split them up. You'd have x minus 8 is equal to 0 and x plus 8 is equal to 0, right? And then just solve both of those. That would be if I had asked you to solve x squared equal to 64. But I didn't. I asked you to factor, and so you'll just go ahead and stop with the factors. All right, let's keep going. This one, let's go ahead here and take a look at it. I recognize 81 as one of my perfect squares, and 9 is also a perfect square. So we're going to rewrite this. 81 comes from doing a 9 squared. The x squared comes from doing an x squared. So I'm going to have 9x squared, right? If I did this, I would square everything inside the parentheses. X squared gets me the x squared. 9 squared gets me the 81, and I get right back to what I started with. Minus, I recognize that 9 is a perfect square. It would be a 3 squared. And so I write my factors as 9x minus 3 and 9x plus 3. Again, that's all equal to 0, and I could ask you to solve if I wanted to. But I just asked you for the factors. I got one more here for you. Let's go ahead and try this one. Again, I need to make sure that it is equal to 0, and it is not. I'll simply subtract 36 to the left-hand side. Now that I'm equal to 0, right away I recognize 36 is a perfect square. It's 6 times 6. And I've got my factors. So again, perfectly great method for factoring a quadratic if you have a difference of squares. And again, these should jump right off the page at you because you're going to have two terms, both of which are perfect squares, which you should immediately recognize from our list, and it will always be subtraction. There is no such thing as a sum of perfect squares. It doesn't work that way. It's only a difference, so it will always be a subtraction sign, and both of the terms will be perfect squares, all right? These should really sort of stick out like a sore thumb, right? You should be able to, just glance at a page and almost immediately recognize, oh, that's a difference of squares. That one's a difference of squares, right? You've only got two terms. The terms are subtracted, and those perfect squares should jump out at you. At least they will with plenty of practice. So that takes care of our second method for factoring quadratics, difference of squares. But what happens if GCF and difference of squares doesn't work? Well, you got to go to option number 3, which is perfect square trinomials. Head on over to the next page of the notes. We'll take a look at perfect square trinomials. I'll meet you guys there.